In this tutorial, we will be discussing how to calculate molar mass. Now, the term molar mass is a very generic term. Molecular mass, formula mass, atomic mass, ionic mass, those all mean the same thing when it comes to molar mass. Molar mass encompasses all of these. The only difference is what it's talking about. So, molecular mass is specifically the mass for a molecule. Formula mass is specifically the mass of a formula unit, so on and so forth. Molar mass is the generic term for all of them. Either way, you're going to be calculating the total mass of the compound per the mole of the substance. And to do this, you're going to be needing the periodic table. So, we're just going to take it step by step and do several of these examples. The first thing you want to do is look at your compound, NH3. You have nitrogen and you have hydrogen. 1 nitrogen, 3 hydrogens. You find that from the chemical formula. From here, you're going to look at the periodic table. So here's hydrogen, here's nitrogen. You're going to want to look at the number that's not the whole number. There's going to be two numbers on the periodic table. The bigger the two is the atomic mass. The smaller the two is the atomic number. You want the mass. So, for nitrogen, it's 14.0. It's up to you and your instructor as to where to round the number off. I usually either go to the 10th place or the 100th place. For this particular video, I'm only going out to the 10th place. For hydrogen, it's 1.0. So 1 times 14.0 is 14.0. 3 times 1.0 is 3.0. From here, you're going to add those two numbers together. 17.0. Officially, the unit is AMU, atomic mass unit, but I'm just going to go ahead and put it in grams per mole because that's what we will eventually be using as the conversion factor. And so I want you to start getting used to seeing it that way. But once again, officially it's considered AMU, atomic mass unit. Alright, so let's go through this process again. We have copper, sulfur, and oxygen. We have 2 coppers, 1 sulfur because there's an invisible 1 there, and 4 oxygens. From here, you're going to look on the periodic table. Copper is 63.546. Sulfur is right here, 32.1. And then oxygen is 16.0. Multiply that out. Once again, I said I was going to go out to the 10th place. So I'm going to round it off to that. 127.0. 1 times 32.1 is 32.1, and 4 times 16.0 is 64.0. Add those together, and it comes out to be 223.1 grams per mole, or AMUs. Sulfuric acid. We have H, S, and O. We have 2 hydrogens, 1 sulfur, 4 oxygens. I got those numbers right there. Now I've got to look for the masses. Hydrogen is 1.0. So 2 times 1.0 is 2.0. Sulfur is 32.1. 1 times 32.1 is 32.1. And oxygen is 16.0. 4 times 16.0 is 64.0. Add those together, and it comes out to be 98.1 grams per mole. Carbon dioxide. Carbon and oxygen. We have 1 carbon, 2 oxygens. Carbon's right here, 12.0. So 1 times 12.0 is 12.0. Oxygen's right here, 16.0. 2 times 16.0 comes out to be 32.0. Add those together, and it comes out to be 44.0 grams per mole. But I do one last one. This is actually the chemical formula for caffeine, just for kicks and giggles. I messed up when I wrote that. So CH N and O. There's 8 carbons, 10 hydrogens, 4 nitrogens, and 2 oxygens. From here, I look on the periodic table. Carbon is 12.0. So 8 times 12.0 comes out to be 96. Hydrogen is 1.0. 10 times 1.0 is 10.0. Nitrogen is 14.0. 4 times 14 is 56. And oxygen is 16.0. 2 times 16 comes out to be 32. Add those together, and it comes out to be 194.0 grams per mole. And that's how you calculate molar mass.